Suppose we have these equations here, and we are asked to solve this by elimination. As usual, first thing is to label the equations. Equation 1, equation 2. And if we want to eliminate a variable, there is x, and there's 3x, and there's 2z and 4z. We can't simply minus equation 1 from equation 2 because none of these are the same amount. You have 1x and 3x, 2z and 4z, both of which don't minus to get 0. But there is a way to deal with this where we can multiply one of these equations so that one of the variables matches with the amount of variables of the other equation. So for example, let's choose equation 1. And let's say I want to get rid of the x. So to get to 3x, I would have to multiply this by 3. But to not change anything, I have to multiply everything in this equation by 3. And note that if I wanted to get rid of the z, I would times this equation by 2, as 2 times 2 would give me 4. And then those minus to get to 0, and then you're left with the x's. But let's just stick with the x's for now. So we can rewrite these equations as 3x plus 3 times 2z, 6z, which equals 5 times 3, which is 15. And then equation 2 stays the same. Now we can begin elimination. And let's do equation 1 minus equation 2. So on this side we have 3x minus 3x, which is 0x, plus 6 minus 4z, which is 2z. On the right hand side we have 15 minus 1, which is 14. And then z would just equal 14 divided by 2, which will give us 7. Oh, we're running out of space here, so I'll just use this right hand side. Alright, so we know that z equals 7. And we can substitute this into equation 2, which was 3x plus 4z equals 1. And we are solving for x. Let's rearrange this equation. 3x equals 1 minus 4z. Okay, and then to get x, we divide both sides by 3. 4z divided by 3. And we know from here that z equals 7. So we simply substitute that in. X equals 1 minus 4 times 7 divided by 3. 1 minus 4 times 7, which is 28. 1 minus 28 over 3. And then x will equal minus 9, because 1 minus 28 is negative 27, divided by 3 gives us minus 9. And as always, it's good to do a check after. So let's choose equation 2. And we simply substitute our result that we solved earlier. 3x plus 4z equals 1. X was minus 9 plus 4 and z was 7 equals 1. Now 3 times minus 9 gives us minus 27 plus 4 times 7 gives us 28. That's equal to 1, and minus 27 plus 28 does in fact equal 1, so this is correct. Alright, let's do another example. This one is a bit more trickier, but the principle is the same. So, equation 1, equation 2. And say we want to eliminate x. We have 2x and we have 3x. So, to eliminate x, we need to multiply both equations such that it will result in the same number of x's in each. And for this, lowest common multiple is 6. So 2 times what is 6? That's just 3. For equation 2, 3 times 2 is 6. So equation 1, we times it by 3. In equation 2, we multiply everything by 2. This becomes 6x plus 3y equals 3 times 3, 9. And then equation 2, 3x times 2 is 6x. And then we have a minus 4y times 2, which is minus 8y. And then 1 times 2 is 2. And now this is set up ready to be solved by elimination. Equation 1 minus equation 2. 6x minus 6x is 0. And we're left with 3y minus, now be careful here, it's a minus 8y will equal 9 minus 2. And now 3y minus a negative 8y is positive, so we add it. So we have 3y plus 8y equals 7. And then 11y equals 7. And y is 7 over 11. Alright, so we've established that y equals 7 over 11. And I'm going to substitute this into equation 1 so that we can find x. So 2x plus 7 over 11 equals 3. 2x will equal 3 minus 7 over 11. Now 3, now when we subtract fractions, remember we need them to be the same denominator, which is 11. And we get that by multiplying 3 by 11 and also dividing by 11. So this becomes 2x equals 3 times 11 over 11 minus 7 over 11. 2x equals 33 over 11 minus 7 over 11, which is 26 over 11. So x will be this divided by 2, which will be 26 over 11. And dividing by 2 is the same as multiplying by a half, which means this will become 23 over 11, and we are done. Now we can double check this. Something's not quite right. 53 divided by 11 is clearly not 3. What did I do wrong? Oh, it's clearly not 23 over 11. Whoops, my bad. It's supposed to be 13 over 11. I think my brain's not working today. Alright, let's continue on. Y equals 7 over 11 and x equaling 13 over 11. And we are substituting back into equation 1, which was 2x plus y equals 3. And now we can quickly check if our variables are correct. 2 times x is 13 over 11 plus y, which is 7 over 11, must equal 3. Now 2 times 13 is 26 over 11 plus 7 over 11. Now 26 plus 7 is 33 over 11 equals 3, and 33 divided by 11 is in fact 3. So we know that y equals 7 over 11 and x equals 13 over 11 is indeed correct. I hope this made sense, and I'll see you in the next video.